Let's look at the concept of elasticity in this video. So the question is, what does the elasticity of a function show at a certain point? So they say, what is the elasticity of our function f of x at the point of x equals to a? First of all, let's write down what elasticity is. And instead of having f of x, let's call it y, because it's going to be easier to explain. So f of x equals to y. The question is, what is the elasticity of y? The elasticity of y. The elasticity of y is the relative change in y due to a relative change in x. Now when we have relative changes, we're speaking of percentage changes, and let me explain that. So these are both percentage changes. This is in y and this is a percentage change in x. What is a change in y? A change in y is the final value minus the initial value. Let's think of this. Let's say that the initial value of y is equal to 5 and the final value of y is equal to 7. What is the change in y now? The change in y is 7 minus 5 equals to 2. Now what is the relative change? Basically, by how many percent did y change? Well, we would divide the change over the initial value, which is 2 relative to 5. And if we divide 2 by 5 in percent, let's just write that down, calculate it real quick, 2 over 5, that's 0.4, 40%. So the change, the relative change is 0.4. That's what we mean by relative. We mean how much it changed relative to the beginning. And that's why it gives us values in percent. And this is useful. This is training you for microeconomics, for economics overall, where we're going to work a lot with percent and with elasticities. Now, this is the general formula. This is to understand that we're speaking about percent. Now let's rearrange this and make it look a bit better. Let me zoom out so we can see everything. Get some space here. We have the elasticity of y, which is the same as the elasticity of f of x. Remember, we just noted it like that. Let's write this as delta y over y, and if we divide by delta x over x, we multiply with the inverse, which is x over delta x. How can we still write this? That will be x over y. Let's group the regular terms together and the deltas together. So it's x over y times delta y over delta x. Delta y over delta x. Now, have a signal in the mind that whenever we're speaking about changes, delta y over delta x, not relative changes, not delta y over y, but just delta y, the change in y relative to a change in x, we're speaking about derivative. And what was the derivative? Y derivative with respect to x, which is the same as f derivative with respect to x. So if we write this in our original notation, just to be comfortable to understand that they're both the same, y and f of x, it is equal to fx divided by f of x times f derivative of x, and that's the elasticity. And now the question is, what does the elasticity at the point of a show? Let's say x takes the values of a. Well, let's go down. The elasticity at the point of f of a, instead of x, we just plug in a into our function. We will have a divided by f of a times the derivative of the function at the point a. And we said that the elasticity shows the rate of change in our function due to a rate of change in percent in our independent variable, in our input, in our a. So if a changes by 1%, if a increases by 1%, how does the function at the point of a change? By how many percent? If it changes with a positive number, it means that the function increases by certain amount. So let's give an example. Let's say if a increases by 1% and the function of our a increases by 0.3%. That's going to be our elasticity. The elasticity of the function at the point of a, whatever that point is going to be equal to 0.3. So this elasticity is 0.3. But let's say the opposite happens. If a increases by 1%, and our function at that point decreases by 0.3%, that means that the elasticity at that point is equal to minus 0.3. So it's very similar to derivative, where we show rate of changes but it is the rate of change in percent and not in units. That's the difference between elasticity and derivative. Hope this makes sense. We are done.